Okay, so we looked at different types of energy before. Now we're starting to look at how we can do calculations with these types of energy. So many of these energies have formulae that you can use to calculate them. So, for example, if we start at kinetic energy, which we can give the symbol EK. Let's actually let's go a bit closer. No, actually, I'm going to leave it like that, and then I'll just make it smaller once I've finished with it. So I'll do that, and I'll make it black. So, okay. Let's choose, what colour is that? That's black, okay. So kinetic energy, that thickness. Okay, kinetic energy is equal to half. So just think of half as just a number half, like it's a 0.5. So 0.5 times the mass times the velocity or the speed squared. That's the formula for kinetic energy. Okay. Now rearranging that formula can be a little bit tricky, but so for example, if we knew what the kinetic energy was, and we knew the mass, we wanted to find the velocity, we would have to rearrange the equation. Well, let's look at what other ones we've got here. Elastic energy. So let's just move on. So we've got elastic energy, which I'm going to call it ELE. And the reason, in fact, ELA. And the reason for that is because EE would be electrical energy, and also EL would also be electrical energy. So I'm going to call it ELA. Okay, so this is elastic energy. And to calculate that, it's going to be half times K times E squared. So we're going to go into these a bit more detail in a moment, but just briefly, K is, let's just look at an example. Let's imagine we had a spring, and it was up here, it was as short as this, but I've stretched it. So that's the extension, and the extension we can label as E. And the original length we can label as L. And then how strong the spring is, we can label is called K. So that's called the spring constant. Okay. As I say, we're going to look at that into a bit more detail when we study that. But let's just group that and put that there. Next one I'll look at is gravitational energy. There are formulae for thermal energy and electrical energy, but I'm just going to look at gravitational energy next because I'm more interested in the ones that involving forces and stuff like that at the moment. So gravitational energy we'll call EG. This one's one of the easier ones to remember. It's just going to be the mass times the strength of gravity times the height. So if we had, there's the floor, and then we've got a ball that has a certain mass, whatever it might be. Maybe the mass might be equal to 2 kilograms, and then it's been lifted up a certain height. So maybe the height is equal to 3 meters. So if it was lifted up even higher, it would have more gravitational energy, but also if it was heavier, it would have more gravitational energy. And also depending on which planet you do it on, it could affect the gravitational energy, because you can imagine that as you pull something away from a planet, it has the potential to fall back into the planet. And the further you pull it away, the more force it's going to pull back into that planet eventually. It's going to strike the surface of the planet with more force. It's going to make more sound. It's going to reach a higher velocity or higher speed. So that's going to, and that can be affected by gravity as well. So on Earth, gravity is 9. It's actually, depending on how precise you want to be, 9.81 newtons per kilogram. Sometimes you can call it you can say 9.8, or sometimes you can say 10. Okay, ... same units. Okay, I'll stop there.